It is 5 minutes before class begins. You need a quick activity, so you open your AI, type in a request for a worksheet, and cross your fingers. What comes back is a generic draft that requires you to do the heavy lifting anyway. At this point, the AI is acting like a guessing intern. To fix this, you have to replace blurry, conversational requests with rigid boundaries. That scaffolding is the RACE framework. It stands for role, action, context, and execute. By answering these 4 specific prompts, you translate teacher clarity directly into AI instructions. AI systems drift when they have too much freedom. Dictating exactly who the AI should be, what it must do, and the exact constraints it must consider removes that drift. This ensures consistent, classroom-ready materials while lowering your own cognitive load. Let's apply this to a standard lesson plan. We need a 50-minute session on medieval history, specifically covering the topic of feudalism. First, we assign a specific role. You are an experienced humanities teacher. Next, we assign the action. We avoid vague verbs like make or write and pull directly from Bloom's taxonomy to use the verb design. Then we provide context. We specify the students are in year 8 and already know the basic feudal pyramid. Finally, we execute. We demand the exact format, a 10-minute retrieval warm-up, 20 minutes of core activity, and a 10-minute exit ticket. The AI no longer has to guess what a useful lesson looks like. By defining these 4 specific boundaries, you filter out generic filler and generate a targeted document you can use immediately. Designing lessons is straightforward, but evaluating student work carries a different risk. We want the AI to provide formative feedback without having it do the actual thinking for the student. Suppose we have a Year 10 student paragraph analyzing the causes of the 1917 February Revolution. We need the AI to provide coaching to help the student improve their own writing. To control this, we use negative commands in the execute block. We explicitly state, no grades, no rewriting. We then command it to return 3 short sections: what is working with the task, an evaluation of the student's process, and the specific next step for improvement. Using negative constraints in the execute phase provides the student with specific pedagogical feedback while keeping the actual work in their hands. The framework also handles complex formatting tasks, like adapting a dense text on ancient history for different literacy levels in a single class. We tell the AI to keep the historical accuracy intact, but in the execute step, we mandate 3 separate reading levels. We give strict targets of exactly 120, 180, and 240 words per level, and require a student-friendly glossary for each. Setting precise word counts and layout constraints forces the language model to adjust its vocabulary and sentence structure. This allows you to differentiate materials for a full class before the lesson even begins. Even with structure, a prompt can occasionally misfire. If the text you get back reads like generic textbook filler, your role constraint is too broad. You must tighten it to define the specific expertise required. If the output is the wrong length, the failure is formatting. Sharpen the execute step for the exact layout. If the AI misses the point, upgrade the context by injecting syllabus codes and defining prior knowledge. Before you type, ask 4 questions. Who is the AI? What must it do? What are the specific constraints? And what is the exact format? These 4 checks ensure the AI operates as a highly capable assistant.